A ball is thrown horizontally off an 8-meter tall ledge with a velocity of 30 meters per second. So 6A asks us to fill in the variables on the diagram. So we are going to go ahead and write what we know. If you look at the object right here initially, it's still on this 8-meter tall ledge. So it's not going up or down yet. Its y direction velocity is 0. So we're going to write 0 meters per second. We actually don't know what the final velocity is because this 30 meters per second is in the x direction. Although we know the acceleration due to gravity, we can't figure out the final velocity without doing an equation. So we do know gravity, the acceleration due to gravity in the y direction, it's negative 9.8 meters per second squared. Our delta y, we know because this ledge is 8 meters tall. But this object falls 8 meters. So this is actually when y equals 0, and then it falls 8 meters below 0. So your delta y is actually negative 8 meters. And we don't know how much time it takes because they haven't told us yet. The initial velocity in the x direction, they've told us it's 30 meters per second. And since we know that in the x direction velocity is constant for projectile motion, we know that the final velocity is 30 meters per second. If the acceleration is the rate at which velocity changes, and velocity doesn't change, we know that our acceleration in the x direction is 0 meters per second squared. And so the two blanks we have for our x direction variables are delta x, how far did it go? That's where this little question mark is, and also how much time it took. Now if we could just solve for the time in the y direction, which is always the column we use to solve for time, then we know that it's the same time for the x direction. Let's see, so we filled in everything that we could with the diagram. So we'll go ahead and check that. Now it wants us to calculate the time it takes to hit the ground. So what we're going to do is choose an equation. Since we always use the y direction to solve for time, we have to look at which variables we have and which ones we're missing. Since it's asking for time, we have to look at the variable that's missing completely. That happens to be our final velocity. So we're going to choose the equation without final velocity. And it happens to be, and everyone, you can check in your physics notebooks at the front with your equations chart. It is delta, and in this case it's going to be delta y, equals initial velocity times time plus 1/2 a t squared. So we plug in our numbers and we're going to have a delta y of negative 8. Our initial velocity is 0, and 0 times time is still 0. 0 times anything is 0. Plus 1/2 negative 9.8 t squared. When you multiply 1/2 and negative 9.8 together, you're going to get negative 4.9. So then we have negative 8 equals negative 4.9 t squared. Now, since this negative 4.9 is being multiplied to t squared, we have to divide it to get it off of this side. So we're going to divide both sides by negative 4.9. This cancels out. Negative 4.9 over negative 4.9 is just 1. So all we have to really worry about is negative 8 over negative 4.9. So we're going to grab our calculator. And we're going to put in negative 8 and divide that by negative 4.9. And we get 1.63. So we know that t squared equals 1.63. But this is a 1.63 seconds squared, and we want seconds. So we're going to have to take the square root of both these sides square root of 1.63 and the square root of t squared. And we end up getting t equals, and let's find out. We take the square root of this 1.63, 1.3, enter, and we get 1.27, which will round to 1.3. So it takes 1.3 seconds for this object to hit the ground. So we're going to go ahead and write that in our equation. It takes 1.3 seconds. And we know that since it took that much time in the y direction, it's the same object, it hits the ground at the same time. So it's 1.3 seconds in the x direction as well. So calculate the time. It is 1.3 seconds. But we're not done. We have one more calculation to do. It wants to know, calculate how far away it lands. So it wants to know, what is our range? What is our delta x? So we have to use an equation, and since our velocities are the same in the x direction, we actually have the luxury of using a very simplified equation. It is velocity equals distance over time. We know our velocity. It is 30 meters per second in the x direction. Our distance is what we're trying to find out, and we just calculated our time. It is 1.3 seconds. So what we're going to do is we want to get this distance by itself. So we have to multiply both sides by 1.3. This cancels, and we can put 1.3 over on this side. So distance actually equals velocity times time. And if you guys get confused about this, you can go ahead and make your triangle like we discussed in class. And d would be on the top because d is the top of your fraction, and then v and t would be the other two. You're trying to solve for distance. If you were to cover up this distance, all you would have was velocity times time. So we know distance is velocity times time. So we grab our calculator and we multiply 1.3 by 30, and we get 39 meters. So we know that this object traveled a distance in the x direction of 39 meters. And we're done.